So I was curious just how much it does cost, and what's involved in building your own sort of ChatGPT language model serving infrastructure, like with a physical server, putting it in your own data center, using your own hardware, loading models. Like, what do you need? How does it work? My assumptions were that it would be ridiculously expensive and the output would be too slow. But I mean, this is what we got to on a Saturday night, 10 p.m. till about 4 a.m. And I think the results are quite interesting and impressive. So I'll show you what we've got to first in terms of speed. And this was also demoed to 9 students as part of Enterprise Week this week. And so it was good with active users as well. What's nice about this is it's hosted, self-hosted on its own server. This one happens to be in the UK. And yeah, we'll run through the specs of the server and how it was set up. And just like, I don't know, let's do this particular model that's loaded as a 5B Quen model. It's particularly good at programming and it's an instruct model. So a typical example, write me a hello world Python example. I mean, it's not particularly taxing, of course, but in terms of the speed that we're getting back here on the hardware, so the hardware that was being used here is about 10 years old, give or take, maybe about 8 years old. And this is pretty impressive. So let's run through the hardware quickly. So, and we'll SSH onto the server as well and show what's going on. But yeah, just to show that we are now SSH'd onto the server, which is in a little data center in Newcastle. If we look at the memory, the total available memory on this server this is RAM, not GPU memory, is 755 gigabytes. So let's write this down. We've got RAM specs, which is, what was it, 750 GB. And in terms of the GPU that we have, just like you've got top on Linux, you've also got, if you're using NVIDIA, there's this NV-top command that's quite nice. It shows you the usage of the GPUs, CPUs, or what are they called, CUDA cores. So here we go. So the GPU, we only have just one little GPU in the server. Remember, this is inference as well. We're not training on this, so we're just doing inference, which is less compute intensive than training. And if I knew how to use TLD draw, that'd be a bit quicker. So there we go. So that's what about CPUs? So if you're using things like Llama, which is, I think their mission is to be working on any kind of hardware. But just to show, I think Llama originally was more CPU, if I'm not mistaken. So we've got 2 physical CPUs on this server and a total sum of 87 cores, if that's the right phrase to use. So we've got 2 CPUs and what's it, 87 cores. So I'm sure someone will correct me on the right language to use there. And I mean, the age of those CPUs as well is not particularly new and shiny. We'll do the total cost as well, because I just think the economics of this are really interesting. If you compare this to renting the same sort of service, for example. So what was I about to do? Yeah, the CPU information. So if we just have a look at that CPU info, the processor being used here is this processor, which if we Google that processor model, you see when it was released, and just get that up. I think that's what we have. Is that the right one? It's the V4. V4. There it is. Hopefully I've got the right one there. And E5 to V4. Yes. So if we look at when that was released, I think it's doing Q. There we go, launch date. So that was released in 2016. 17, 18, 19, 20, 1, 2, 3, 4, 8 years ago. So it's an 8-year-old CPU. That ChatGPT instance that we just did, age of processor 8 years. I should say the cost of the cost. So we'll do costs over here. Costs. So the RAM, well, the whole server we'll get to, but the GPU at the time of purchase cost around £1,500. Okay, but today, since as is always the case with hardware, it just goes down and down and down and down and down. And of course, it's tempting to go, oh, well, you need an A100, which at the time of when I bought that was about £14,000. But you can see we can get, so just go back to this, the speed, show me that in the Rust programming language. And also with concurrent users, you get this successful sort of feedback speed, usable, workable feedback speed that you tend not to get on laptops. Even the Apple Macs tend to be a bit slow. It is a small model, but it's a useful enough model. So if I was to kick off a few chats, you'd see that the performance is actually quite usable. And so the server itself in total cost about £5,000, give or take, but it does also have a lot of storage. So storage, we have about 30 terabytes of storage. They are SSDs, so standard SAS drives with around about, I know the read speed is around 450 megabytes tested. It's all on a CFS volume manager file system type thing. And just to jump on back into the server, whilst those inferences are running, so if I can maximize the right window here, because all good deployments are ran by tmux, of course. There's no load on the GPU right now, but as we fire inference at that, so let's run some jobs. So what I'll do is I'll ask it to regenerate, and you'll see the server is, the GPU is doing all of that activity because we're currently running a GPU language server. We're not using the Llama based model at the moment. We're using VLLM for this, which is this project here. So this is the high throughput, memory efficient inference serving engine for LLMs. But we're also able to use Ollama, which takes advantage of your CPUs. It's difficult to see, but if I also open up HTOP, all the little cores are at the top there. They're actually not being used for this because VLLM is taking advantage of the GPU. So you can see there's very little activity on the CPUs there. What you are seeing is a bit of write happening, a bit of read happening on the model as it gets read from the file system. That's quite interesting to take a look at, actually. Let's zoom in on that a little bit. So we'll do a new. Okay, so that's part of the UI spawning off the task and processing their response. I should add the UI that we're using here is this, what's it called? Open Web UI, which is a community project. Is it a community project? It's probably a VC-backed interface that has some monetization strategy behind it that I'm not familiar with. But there are many UIs that you can put on top of these models because they're starting to converge to a sort of standard API. A lot of them use the same API programming interface as ChatGPT, and you can just swap and change the UIs accordingly. So let's switch to a CPU-based model. And if I can remember how to do that, what we're going to do now is try and take advantage of all these very old but numerous cores on there. And we'll see just like the performance difference. I'm just checking we're still recording. Yes, we are. Okay, so I'm going to stop the VLLM server. If I can find out what tab is active. Okay, so I'm disabling now VLLM, so we're actually not serving that model anymore. And we'll see that that's now broken. no man behind the curtain. So this will actually not hit the GPU anymore. There we go. So the model's no longer being served. So what we're going to do now is enable a Ollama, and Ollama is going to load that memory. Sorry, it's going to load that model into the RAM rather than the GPU. And in fact, if you notice on the GPU's memory usage has dropped down to 0 because it's no longer loaded into memory. So let's do Ollama. Ollama. OLAMA, and we're going to list the available models, and we're going to serve. First, I'll do a status. Let's do a system control status Ollama to check that the service is running, which it is. That's brilliant. And what else do I need to do? I need to enable those models. I should say where those models are stored. So I mentioned that we've got quite a lot of storage. We have, what do we have? About 30 terabytes of storage. It's probably a bit less actually because some of the hard drives broke, which is a good exercise in data recovery. CFS list. And that's part of the reason why we used CFS, although the amount of hard drives that died was too many. So we have different preferences of SSD vendors after that. So all the models are being stored in this dataset, CFS dataset called tank models. And this is where Ollama is loading them from, also Hugging Face. So we've just done a symlink to this ZFS tank. This makes it easier if we wipe the server to not have to download all the models again, because the models are very large. So here you can see we've got DeepSeek, the 671 billion, is that right? The large one, which is 404 gigabytes. We've also got some smaller ones here as well. So let's enable those in the UI. Pardon me. Where are we in the UI? Here we are. So if we go to the admin dashboard, and we go to models, and we just enable CodeLlama, and we enable a smaller DeepSeek, and we'll load Quen code. So this is a 14 billion model, and we'll also do the 32 billion. That's interesting because that one will not fit on this graphics card. So remember that the graphics card has a total memory, I don't think we went across this over this, is 16 gigabytes. So there's not enough memory in that graphics card to fit. And it's interesting what Ollama does to handle that situation. So we'll probably play with that one first. Yeah, okay. So now they're available, we can do a new chat and we can actually select some of those. And what we're going to do on the right hand side is do a watch on Ollama PS. At the moment, it's just got one model loaded, and notice how it's loaded in the CPU 100%. We're going to load that other model now, the one that is Quen 14B. So I've selected it, but it's not actually loaded in yet. But you'll see what happens when we start to load it in. So we'll just say, are you loaded in memory? And that will just trigger Ollama to notice that it needs to load that into memory. And notice we've got that blip of GPU, CPU used, and now we've got 100% pretty much of the GPU memory being used. And it actually won't all fit that model. It's already finished. And what Ollama was able to do, which is really impressive, and I don't deeply understand this yet, it's managed to divide up the model, which is larger than the 16 gigabytes of the Tesla 16 gigabyte GPU, and it spread it across a bit across the processor, and mostly across the GPU, which is kind of exactly what you want, right? So let's compare that to the VLLM. It's not a particularly scientific comparison, I grant you, but if you remember the speed of the response to the previous chat, let's do it, give it the same prompts, and again do a very unscientific comparison with a new chat to the 14B model. So off we go. And you see it's a little bit slower. You can see the GPU, CPU CUDA cores being used. And the difference this time as well, if we jump over to, again, it's harder to see because it's also cramped. You should see the CPU jump as well. Convert that to Rust programming language. I just want to be a little bit helpful in terms of providing a specific prompt. So that's going in. And yeah, it's a bit hard to see. If I make that a little bit bigger, you can see that the CPU also now is being used. And Ollama, the runners, if you see here, are actually being called out to spread that workload across. It's really impressive what the VLLM project does in terms of the cache hits and how they arrange the memory on the GPU. If you have GPUs that are large enough in terms of the memory they have. If you don't, then you've got this alternative approach that Ollama seems to do, where you get the best of both worlds. Well, you get a different approach in terms of loading large models and taking advantage of the compute that you had. Because there we go, we have a server that's particularly old, but has quite a lot of traditional CPUs. I think it's called SMD, Intel SMD. No, it's not called that. There's particular instructions. So general purpose CPUs are not generally good at matrix calculations, but on CPUs there are some modules, enhancements, I forget the correct word to use here, which allow them to do CPUs. Maybe we could ask the LLM about that actually. Let's do that in a new model. What's that CPU extension called, which refers to the ability to do matrix calculations? I'm pretty sure it begins with S. How many R's are in this letter strawberry? I think it begins with D. Let's see. Data parallel, yes, perhaps. It sounds. No, it's none of the. I think again, it's a convincing answer that you'd expect from. Here we go. No. Single instruction. That is the one. That is the one. SIMD. So if your processors are old, Intel, I think that's the one. No, again, the convincing answers have confused me. Single instruction, multiple data, extension. Maybe it is that. I need to do some more reading. So yeah, anyway, that is an overview of server running a pretty convincing speed with multiple users. And so I don't know, compare the cost of this. Okay, the hosting of this server costs about £100 a month in terms of the storage facility, storage, the space in the rack. So obviously there's upfront costs in terms of the hardware, like we're talking about £5,000 here. I find the economics of this really interesting. So there's the rent and the storage of that and the upfront cost. But ultimately, if you care about where your data is, knowing where your data is, and if you have the skills in your organization to rack and stack servers, which of course is a bit of a dying art, you can do that. And with a reasonable amount of cost. I mean, I wonder what spec server that would be if you were to spec it out on a, say, GCP or AWS, GCP tier calculator pricing. Is there a generic cloud instance price lookup tool? There must be. Here we go. What a brilliant domain name that is. Hopefully it lives up to gosh, my CPU is spinning now. They must have a lot of interesting JS. But anyway, someone, if you're watching the video, do the calculations. How much does it cost to rent a similar server with similar performance